Hello everyone, my name is Renji Z. Villorente, BSc 4A, and my topics about hydraulic gradient, Darcy's law, and permeability of stratified soil. So first, let's define hydraulic gradient. Hydraulic gradient is defined as the slope of the free water surface in the direction of flow. So it is expressed as I is equals delta H over L, where I is the hydraulic gradient, delta H is the head loss, L is the distance between points A and B. And take note that L is always parallel to the direction of flow. Next is Darcy's law. Darcy's laws demonstrated experimentally that for laminar flow conditions in a saturated soil, the rate of flow or the discharge per unit time is proportional to the hydraulic gradient. Darcy also stated that the flow of water through porous media is directly proportional to the head loss and inversely proportional to the length of the flow path, and this may be written as V is equals to K times delta H over L, or V is equals to K times I, where K is the permeability coefficient or hydraulic conductivity and V is the discharge velocity or average velocity. In discharge velocity, it is the quantity of water flowing in unit time through a unit gross cross-sectional area and of soil at right angles to the direction of flow, or as we say, V is equals to Q or over A. Now let's proceed to permeability of stratified soil. So when we say stratified soil, it is made up from different layers. In each layer, there are different types of soil. That in each soil has a different property, and one of those property is the hydraulic conductivity. So for the layered soils, we have to find the equivalent horizontal hydraulic conductivity and the equivalent vertical hydraulic conductivity. So for horizontal flow, this is our soil layers, and the direction of the flow is parallel to the soil layers. So for each layer, we have the horizontal hydraulic conductivity, and then the thickness, the H1, H2, H3, and so on, and the height. So to get the equivalent of horizontal hydraulic conductivity, this is the summation of the individual hydraulic conductivities of the soil times the respective height all over the summation of the heights or the thickness, and can be written as K sub H is equals to 1 over H times K sub H1 times H1, and so on. So in this one, the equivalent vertical hydraulic conductivity is equal to the total of H all over the summation of the thickness all over the hydraulic conductivity, or this one. So in this example, we are asked to find the ratio of the equivalent hydraulic conductivity for a stratified soil. So this is the soil properties. So first, we convert meters to centimeters. Then, the equivalent hydraulic conductivity is given by the equivalent horizontal all over the equivalent vertical. So first, we find the equivalent horizontal. So just substitute the values. Then we get 0.0 148 centimeter per seconds for the equivalent horizontal, and for the equivalent vertical, just substitute again. Then we get 1.0176 times 10 raised to negative 4 centimeter per second. And this is the answer. The equivalent hydraulic conductivity is equals to 145.44, the ratio. So in this problem, we are asked to calculate the flow rate in cubic meter per seconds length to the permeable layer below. So first, we will use Q is equal to K times delta H all over L times width times the thickness. Notice that the length is not parallel to the flow. This is the flow. So we have to find the length, this one. So let's denote as L prime. So it will be cosine 8 degrees is equal to L all over the L prime. So it will be L prime is equals to 50 over cosine 8 degrees. And the thickness will be 3 meters cosine 8 degrees. So back to the formula, we substitute the value and we get the answer. The Q is equals to 188.2811 cubic centimeter per seconds, or Q is equals to 1.882828 cubic meter per seconds. This is the answer in meters.